Hello everyone. In today's session, we'll be learning a simple ARM code in order to find negative number in a given array of data. Okay, and as you can see here, it's DCD. So all these data are 32-bit. Okay, and they are under the label array. Fine. So let's see what's exactly happening here. Area instructs that a specific segment should be given in the memory to store this particular instructions. This is a random name. Code informs that these are instructions and not only just data values. Read only informs that this particular code should not be modified during a runtime. Okay. Entry indicates where exactly the code is starting. Start is a label. The very first instruction we have is LDR R4 comma equal to array. So R4 points at the address of this particular label array. Okay. R5 is another counter. It's 5 because we have taken 5 elements here. Okay, R0 is one more counter which stores the total number of negative numbers present here. Okay, this is nothing but a label. Let's see what happens here. Okay, content of R4 is copied to R1, that is the very first value pointed by R4 is copied to R1, which is -2. Then we are incrementing R4 by 4 so that it points at the next location. This values LDR here and #4 here are because it's a 32-bit data. Okay, based on its 32, 16 or what bit value are stored in the array, the instructions will change. What we are doing is we are comparing R1 with 0. Okay, this is a very easy code because we already know any number which is negative should be less than 0. So we are comparing if R1 is less than 0. If it is less than 0, in that particular case, now because it is compared automatically, conditional flags are set. Then based on that, this addition happens. It is add LT. LT is signed less than operation. It will check N and V flag, that is a negative flag and overflow flag. If this particular operation should happen, N should not be equal to V. That happens in all cases where R1 is less than 0. Okay, fine. And next, what addition is happening? R0 is incremented. Okay, then we are subtracting R5 by 1 because already one element we have compared, and we are branching back here. Okay, and this stop B stop is nothing but a finite loop. Fine. Let's see how this works. Okay, R4 is initially pointing to array, and so we can actually access that value. Let's see what is stored in the memory. Okay, so what's happening here? Why is it FE, FF and all that? We have negative value -2. Okay, -2 in hexadecimal is all this. Okay, 4 is written as a simple 4 here. You can see all negative values always start with 1. Okay, that is nothing but F is nothing but 1 1 1 1. So you should always remember that if you see F and followed by something or any number which is equal to or greater than 8, okay, in hexadecimal, if you are considering signed numbers, all numbers greater than or equal to 8 in MSB spot, okay, that will all be negative itself. So let's see what's happening here. Okay, so first value is loaded, which is nothing but -2. Then we are comparing it with 0 and our CPSR is updated. In this particular case, if you consider N and V, what is happening here? N and V are not equal because the given value -2 is actually less than 0. Okay, then what happens is nothing but we are done with one comparison, because of which we will go back to the loop, and on this particular case already R0 will be updated with 1 because addition happens since our R1 is a negative value. Okay, then next value is taken. Okay, that is nothing but 4. Okay, in this particular case this condition is not true. That is, we can see that, okay, after comparison here n and v are actually equal, because of which this addition doesn't occur. So if you move to the next case, that is again -8. So when you come back, okay, you can see that n and v are not equal, and directly when you can see just by checking that r1 is greater than 0, but computers won't be able to recognize it without checking the flags. Okay, then subtraction happens of r5, so that next value is taken. In the next case, r1 is actually equal to 0. Okay, because it's equal to 0, z flag will be set, but that is not going to affect your less than flag. Okay, that will not be true because n and v are equal. Okay, and next again value 5 is taken. Okay, as you can see here, and if you see, then addition here again doesn't occur. Okay, and it branches to infinite loop. So if you check here, there are total 2 negative numbers, as we can see, -2 and -8. That's all.